All right, next up, we'll be talking about boiling point, right? So far, we've been talking about vaporization, going from a liquid to a gas. But most of the time when we see that, it's when something's boiling, right? You boil a cup of water, you see that water turn into steam, which is the gas form. So let's take a look at that a little bit. As we increase the temperature, we have more molecules having enough energy to become gases. Right? And we saw that with our illustration, right? The higher the temperature, the larger proportion of molecules that have to become gases. And the more molecules that become gases, the higher the vapor pressure. So look, something like this. It's not linear. It's kind of more exponential. As we increase temperature, we get a larger and larger increase of vapor pressure. Let's take a look at what's going on kind of in our cup here. So we've got our little cup of water, and it's exerting some kind of vapor pressure. Right? Some of these molecules are turning into gas, and that gas is pushing up against the atmosphere. So the atmosphere is pushing down on our cup of water, and our cup of water is pushing up against the atmosphere. What happens when we heat it? A little kind of Bunsen burner down here. We're heating this. Well, we're going to increase the amount of vapor pressure. And when we increase it to the point where it's equal to the external pressure, or in this case, our atmospheric pressure, that's when boiling occurs. So a boiling point does not occur at a specific temperature. It's when the vapor pressure is equal to the atmospheric pressure. So the boiling point is the temperature at which a liquid's vapor pressure is equal to the external pressure, which is most often times our atmosphere. And what we call normal boiling point, when we say that water boils at 100 degrees Celsius, what we're talking about is normal boiling point. And so that's the boiling point at 1 atmosphere, right? Or approximately right at sea level. Of course, our external pressure is going to depend on the altitude. So the higher up you go, the lower the external pressure, and thus the lower the boiling point, because now our liquid has to be heated less to reach that vapor pressure. And so here's this cool little kind of pictogram. You can see that on Mount Everest, water boils at about 70 degrees Celsius, so that's quite a bit of a decrease. And then you can see below sea level, when we get a more atmospheric pressure, the boiling point also increases. This is also kind of how a pressure cooker works, right? A pressure cooker cooks food faster. The reason that it can cook food faster is because your water can go above 100 degrees Celsius. Whereas if you were just cooking a pot of water, it would only be at 100 degrees Celsius.